Hello everyone! Welcome back to my channel. Our most essential learning competency for today is illustrating series. Let us define first what a series is. A series is the sum of list of numbers which follow a pattern or order. Example, 5 plus 10 plus 15 up to 100. So as you can see, there is a pattern here, and what is that pattern? They are all multiples of 5. What is the order? It is in increasing or ascending order. Now, what operation is involved? It's plus. That's why we call it a sum. Okay, it is the sum of the list of numbers. Now, there are two kinds of series. We have the finite and the infinite. Finite series is an expression of the form, this one, a sub 1 plus a sub 2 plus a sub 3 up to a sub n. And this one is its representation in summation notation or sigma notation. An infinite series is an expression of the form a sub 1 plus a sub 2 plus a sub 3 plus a sub n plus infinity. This one is the representation, of course, in sigma notation. Take note, this one is n and this one is infinity. Now, how are we going to apply this to? Example 1. Write the series 2 plus 5 plus 8 plus 20 in summation notation and evaluate. In this case, you need to recall the two kinds of sequences, the arithmetic and the geometric. When we say arithmetic, there is a common difference. When we say geometric, there is a common ratio. Now, is this a geometric series or is this an arithmetic series? Let's find out. We have 2 plus 5 plus 8 plus 20. So let us determine whether this one is an arithmetic series or geometric. Let us subtract the second term by the first. It's 3. 8 minus 5, it's 3. So there is a common difference, therefore this one is an arithmetic series. So that common difference is denoted by small d. This one is the common difference. Okay. Now, we know that this one is our a sub 1, the first term, and this one is our a sub n, the nth term. We do not know the order of this term, 20. So we will be using, of course, the formula for arithmetic sequence. And that is a sub n is equal to a sub 1 plus n minus 1 d. A sub n here is of course 20. A sub 1 is 2. Plus n, the one that we are looking for. The order of this one. So this is 1 and then 3. So we have 20 equals 2 plus 3n minus 3. So simplifying it, we have 20 equals negative 1 plus 3n. This is 20 plus 1 equals 3n divided by 3 divided by 3, n is equal to, of course, 7. So our n is 7 and our d is 3. How are we going to write this now in sigma notation? Of course, this one is a finite series. This one is n, which is 7. And n is equal to 1, of course. We'll start from 1. How do we get a sub n here? To get a sub n, we need to use the formula a sub 1 plus n minus 1 d. So a sub n is equal to a sub 1, which is 2, plus n minus 1 times 3. So we have 2 plus 3n minus 3. Our a sub n now is equal to 3n minus 1. So we will be using it here. 3n minus 1. Now, how are we going to evaluate it? To evaluate it, this is what you're going to do. This one is equivalent to, this one is your first term. So meaning we will be substituting n here by 1 up to 7. So we have 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4 plus 3 times 5 plus 3 times 6 plus 3 times 7. Okay, that's it. So this one is the last term, 7. So let's find now the sum. This one is 3 times 1 minus 1, that is 2. 3 times 2 minus 1, that is 5. 3 times 3 minus 1, that is 8. 3 times 4 minus 1, that is 11. 3 times 5 minus 1, that one is 14. 3 times 6 minus 1, that is 17. And 3 times 7 minus 1, that is 20. So we will be adding 2, 5. This one is equal to 2 plus 5 plus 8 plus 11 plus 14 plus 17 plus 20. And of course, our sum is, what is this? This one is 7 plus 8 is 15. 7 plus 8 is 15. This one is 25. And this one is 37. So we have 7, 1, 2, 4, 7. It's 77. So this one is equivalent to 77. Example number 2. Write the series negative 3 plus 9 minus 27 plus 729 in summation notation and evaluate. Okay, so let's find out whether there is a common difference or common ratio. 9 minus 3 minus negative 3 is 12. Negative 27 minus negative 9. This one is not 12. This is not equal to 12. So therefore, maybe this one is a geometric series. Let's try it. We have 9 divided by negative 3. It's negative 3. And then negative 27 divided by 9. It's also negative 3. So therefore, this one is a geometric series. And the common ratio is negative 3. So I will be assigning the common ratio as R. I will be representing the common ratio as R. And this one is the formula for geometric sequence. A sub n is equal to a sub 1 r raised to n minus 1. This one is the formula. So we have a sub n is of course 729. Our a sub 1 is of course negative 3. Our common ratio is also negative 3. And this is n minus 1. So how are we going to solve for n here? First, you divide everything by negative 3. So this will be cancelled. So negative 3 raised to n minus 1. So this is negative 243. Now, I will be using exponential equations here. I will rewrite this as base negative 3. So negative 3 raised to 4 is 81. Raised to 5 is negative 243. So negative 3 raised to n minus 1. I can now cancel this one because it's one-to-one property. This is n minus 1. So 5 plus 1 is equal to n. Our n is, of course, 6. So our n is 6. Using summation notation, we have here, our n is 6. And of course, our n is equal to 1. So we have to look for a sub n to put this here. This is a sub 1, r n minus 1. So a sub n is equal to negative 3. Our r is also negative 3. And this one is n minus 1. We can simplify it. Same base, we just add the exponent, negative 3 n minus 1 plus 1. So a sub n is equal to negative 3 raised to n. Simple as that. Negative 3 raised to n. Now, to solve for or to evaluate this one, so we need to find the sum of the first 6 terms. So this one is equivalent to negative 3 raised to n, that is 1, plus negative 3 raised to 2, plus negative 3 raised to 4, 3 rather, plus negative 3 raised to 4, plus negative 3 raised to 5, plus negative 3 raised to 6. Okay. So we have 1, 2, 3, 4, 5, 6. 6. We start from 1. Okay. So negative 3 raised to 1 is of course equal to negative 3. Plus negative 3 squared is 9. Negative 3 cubed is negative 27. Negative 3 raised to 4 is 81, positive. This one is 243. And 243 times negative 3 is 9, 12, carry 1, 7. It's 729 plus 729. So you have to add all the positive, this one and this one, 729 plus 81 plus 9. So you have 19, carry 1, 11, carry 1, 819. So that is 819 minus, you have negative 243, negative 27, and negative 3. Okay, so we have here 13, carry 1, 7, 2. That is 13, carry 1, 7, 2. 273. So finally, we have 819 minus 273 equals 6. This one is 4. 7, that is 5. So we have 546. Example number 3, evaluate 5i plus 3. We'll start from I is equal to 1 and up to the 5th term. So this one is equivalent to I is equal to 1. This one is 5i plus 3. In this example, we use here the variable I. So therefore, we have to find the sum of the first 5 terms. We'll start from 1. So that is 5 times 1 plus 3 plus 5 times 2 plus 3 plus 5 times 3 plus 3 plus 5 times 4 plus 3 plus 5 times 5 plus 3. Okay, so this one is 5 plus 3, 8. This one is 10 plus 3, 13. This one is 15 plus 3, 18. This one is 20 plus 3, 23. And this one is 28. So we have 8 plus 13 plus 18 plus 23 plus 28. So this is equal to, this one is 21. This is 21. This one is 41. And this is 28. Again, this one is 41. So we have 10, carry 1, we have 2, 4, 6, 8, 9. So we have 9 here. Example number 4, write the series 9 plus 18 plus 27 plus up to infinity in summation notation and evaluate. So as you can see, we have 9 plus 18 plus 27. Let's see whether it is a geometric series or an arithmetic series. 19 minus 8 is 9. 27 minus 18 is also 9. So therefore, this is an arithmetic series. There is a common difference of course, 9. Now, how are we going to write it in summation notation? So this one is up to infinity. And this one is n equals 1. So our a sub n is equal to, our a sub 1 is 9. Plus, this one is of course n minus 1. This is 9. So a sub n is equal to 9 plus, this is 9n minus 9. So we have here a sub n is equal to 9n. So this is 9n. Okay. So how are we going to evaluate it? To evaluate this, of course, this one is equal to 9 times 1 plus 9 times 2 up to, of course, 9 times infinity. So you can write it this way. This one is 9 plus 18 plus 27 up to, of course, 9 infinity. Or simply, this is equivalent to 9 up to 9 infinity.